equation where it's a 2 to 1, 2 to 1, okay? Now let's write the net ionic equation. I'm deliberately going to skip some space. All right, so we're going to have 2 sodium ions, 2 hydroxide ions, 1 magnesium, and how many chlorides? 2 chlorides. Over here we have 2 sodiums, 2 chlorides, and then we've got our precipitate. Okay? How's everybody doing? All right. So, and then the net ionic would be hydroxides plus magnesium forming the MgOH2. This is the solid. These are aqueous. Okay. So, what we started with again was 100 mils of each, 2 molar. Does everybody agree 2 molar times 0.1 liters is 0.2 moles? Does everybody agree that we start with 0.2 moles of each reactant? Yes? Okay. So let's write that in and let's deal with the molecular equation at first because we're going to figure out the precipitate question. So given 0.2 moles and 0.2 moles, how many grams of precipitate can we make? All right. Unlike the other problem where everything was 1 to 1, we might have a different scenario. Do we have a limiting reactant here? Okay, now think of this in your mind. Any amount of magnesium chloride you have in moles, you will always need double that amount of sodium hydroxide. That's what a 1 to 2 ratio means. Okay? Any amount of this that you have, you will only need half as much magnesium chloride to react it. Okay? So I want everybody to think in their mind, which is the limiting reactant? The sodium hydroxide or the magnesium chloride?
Sodium hydroxide.
The sodium hydroxide. Can everybody figure that out? And here's what you can do to check in your head. If you have 0.2 moles of magnesium chloride, how many moles of sodium hydroxide would you need for all of this to react? 0.4. Always twice as much. Do you have 0.4? So this is the limiting reactant. Does that make sense? And honestly, when I do stoichiometry problems, yes, I use the bridge and stuff like that, but if I can get to moles and think through it in my head, I do that first. It's quicker, okay? Then I proceed from there, okay? So at this point, we've got 0.2 moles of sodium hydroxide. How many moles of my precipitate can I make? It's a 2 to 1 ratio. So how many moles? 0.1 mole. Do you see how it's okay to do that in your head? It's a very easy relationship to see. It's a 1 to 2, nope, it's a 2 to 1 ratio of those two chemicals.
But Ms. Rivers, like if we weren't given the molarity at first, like it might not necessarily follow the ratio. Like if we were given grams instead and they're different grams, like it might not, like
Correct.
sodium hydroxide might not be the limiting reactant.
Correct. Right. And that's why I deliberately gave it to you this way so we could think through it this way. But yeah, you have to start with your starting amounts. Okay? Like if you had had 0.6 of this and 0.2 of this, 0.2 would have needed 0.4. You had 0.6. That would have been too much. This would have been the excess, and that would have been the limiting.
Okay.
Yeah. It's not always the one with the bigger coefficient in front. Okay? All right. So then here, every 1 mole of magnesium hydroxide is, let's see, that's 34 and 24.3. So that's 58.3 grams. And again, without a calculator, okay, can you do this? 0.1 times 58.3 is what? 5.83 grams. Okay? Does everybody understand this part of this problem? Okay, good.